Hi, I am Abhishek Chai from Matlab Helper, and today we are going to learn about implementation of video surveillance using Matlab. After watching this video, you will learn how to build a video surveillance using Matlab. This system can display live video from any source such as webcam, CCTV, etc., detecting motion and sending alarm when the camera is triggered. It is a fun project for understanding or implementing computer vision in Matlab and serves to be a template in designing complex system using computer vision functionalities. I have written the Matlab code. Let us run and see if the code is working correctly. Alright, that was impressive. Let us decode our MATLAB code into a simple explanation. In the first few lines, we have cleared the workspace, command window and figure window. Then using computer vision toolbox objects, we have created foreground detection and blob analysis objects. Now we are creating a webcam object with a resolution of 640 x 360. Here we are creating a video player object for displaying images sequence captured using a webcam object. To display the frames obtained from the webcam, we will be using vision.videoPlayer object from the computer vision toolbox. Now we are using a while loop in this program controlled by the video player object. During each iteration of while loop, it shows the first frame. The second frame gets assigned to the first frame in the next while loop, and a new frame is assigned to the second frame, and it goes on, resulting in a live video display on the screen. The algorithm requires two consecutive frames implemented the snapshot function on the webcam object. We acquire these frames as an image. Once we have the frames in hand, the next step is to find the absolute difference between the consecutive frames. For this, we will be making use of imAbs difference function in MATLAB. The image obtained is still in RGB form, but it is better to carry out image transformation in grayscale. It is simpler and more convenient. To transform a color image to a grayscale image, we make use of RGB to gray function. The next step is to use the Gaussian blurring filter of size 5 x 5 to reduce image noise and reduce details. For this, we will use imGaussFill function. After image enhancement, we move on to computer vision toolbox objects and morphological processing to satisfy our requirements. We will be using two computer vision toolbox objects. One is vision foreground detector and the other one is vision blob analysis. The foreground detector segment moving object into a video frame from the background by comparing to a background model whether individual pixels are the part of background or the foreground. It outputs a binary mask where the pixel value 1 corresponds to the foreground and the value 0 corresponds to the background. By using background subtraction, you can detect foreground object in an image taken from the stationary camera. Three morphological functions are implemented to remove the noise and fill in the holes. First,imopen, second, imclose, third, imfill. Connected groups of foreground pixels from morphological processing likely correspond to moving objects. To find such groups, we use the blob analysis system object called blobs or connected components and compute their characteristics such as area, centroid, and the bounding box. The blob or connected component area in the above step is a characteristic or criteria for the alarm to ring. We use an if loop for this. When the area of any connected component or moving object is more significant than a fixed constant value, we want the alarm to play. We have downloaded an audio file from the YouTube audio library for our video surveillance and use it in our code. A bounding box is inserted onto frame 1 using insert object annotation function for each blob identified in a frame. We have also created a loop or a section that encloses the video surveillance when you do not want to use it. Whenever a user presses or input the G key from the keyboard, the video surveillance is aborted. You can easily extend this method to work with other detection forms, including face detection, motion-based multiple object tracking, and more. You can take it as an exercise to implement. In that case, you can use this project as a base for implementing any additional computer vision functionality. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments or get in touch with us. Follow us on LinkedIn, Facebook, and subscribe to our YouTube channel. Education is our future, MATLAB is our feature. Happy MATLABing!